Question 1. Chlorine 35 has an atomic mass of this value. It has an atomic number of 17. State the number of protons, neutrons, and electrons in a neutral atom. So the protons just the same as the atomic number, 17. The neutrons should be the difference between the mass number and the proton number, so 18. And since it's a neutral atom, the number of electrons will also be 17. It says you may ignore electrons for the rest of this question. Calculate the mass deficit in an atom of chlorine 35 in units of U to start off with. So to work out the mass deficit, we're going to take the mass of the protons and the neutrons and subtract the mass of the nucleus. So in this case, we've got 17 protons. From the data at the top of the page, we know they're 1.007276. Plus, we've got the neutrons, 1.008664. 1.008664. And then we need to subtract from that the mass of the nucleus, so 34.968853. That calculation. Wrong. A set of brackets. Let's try that again. So we get a mass deficit in U of 0.311 if we write it to 3 significant figures. So in terms of significant figures, we tend to keep lots in our working because when we get to the end, we suddenly realize that these figures here were never actually really significant to our answer that we worked out. So we keep high numbers in the working, but we can round to 3 when we're stating results. Usually, we do need to be a bit careful about carrying values through. So the 0.311 U, and then we want to write it in kilograms. So we need to multiply it by a conversion factor, which is number of kilograms per U. And so our conversion factor is that 1 U is 1.66 times 10 to the minus 27 kilograms. Again, we could put extra significant figures in here, but because we're only going to quote the answer to 3, we don't need to. Gives us a value of 5.16 times 10 to the minus 28 kilograms. Calculate the binding energy of the nucleus in units of joules. So here we're going to use the idea that the energy is equal to delta M C squared. We also always give binding energies as negative because it's the energy that you need to put in to take the thing apart. So this is minus 5.16 times 10 to the minus 28 multiplied by C squared. So we tend to use 8.99 times 10 to the 16. Which gives us 4.64 times 10 to the minus 11 joules. And then in MeV, so 4.64 times 10 to the minus 11 joules. We want to write in MeV, so we need to multiply it by MeV over joules. So in terms of conversion factors, what we should know is that 1 MeV is 1.6 times 10 to the minus 13 joules. So strictly, really, we know that an EV is times 10 to the minus 19. So the M is a factor of 6, which is, so this is kind of minus 19 plus 6 is why we end up with the minus 13. So it's 4.64 divided by 1.6 times 10 to the minus 13, which gives us a binding energy of 289.8. So we're going to quote it as 290 mega electron volts. And then calculate the binding energy per nucleon in chlorine 35. So there's 35 nucleons. So that should have been a minus in there, shouldn't it? Minus still, that was minus there. Minus there. Energy is minus 290 over 35, which gives a value of 8 minus 8.28 MeV per nucleon.